right,
are
in
spread
lesson
out.
9.2, this is called variability, and what we're going to be studying is how different data is spread out. So first we're just going to explore some things about variability. We're going to have a few lists here, the 3 lists, and you can look at those. If you were to work through those, you would see that the mean is 6 and the median is 6. Obviously the median we can just find the middle number, and the mean we can add them all together and divide by 5. So although they have the same median and the same mean, they're not the same list. The numbers are spread out a little bit differently, and that's what we're going to be looking at in this lesson. So first of all, we're going to look at range. So the range here is the highest value minus the lowest value. So in list A, you can see that that's 8 minus 4, highest minus lowest. In list B,
Obviously we get
this range is actually 10 minus 2, which is 8. And then list 3 is the same. It's also 8. So once again, we have the mean
still
the
there's a
same, the
difference
median the
between
same,
list
and at least for
B,
list
so we
B
want
and
to
C,
study the idea of
we
spread.
see that the range is the same, but the lists are not the same. So what we're going to do is we're going to discuss a topic called deviation. And deviation, the deviation of a data value from the mean is the difference between that data value and the mean. So you're going to take whatever data value you have. You obviously have a list, and those are all your different data values, and you're going to subtract the mean from it. So really that's going to show how far each data value is from the mean. And so you actually do that value by value. So if you look there in that first list, list A, remember the mean is 6. So list A, you do 8 minus 2. Sorry, 8 minus 6. 8 minus 6 is 2. 7 minus 6 is 1. 6 minus 6 is 0. 5 minus 6 is -1, and so on. The sum of the deviations is 0, which makes sense.
For all of our deviations, the
So if
sum.
you take
So
each of those deviations, they add them together, and you get 0. So how do we measure the spread?
Values.
How spread out
So we could find
all the different data values are? Well, there's a couple different ways, and that's the first way is the mean deviation, and you take the sum of all of the different
this idea of
data values minus the mean, so all the sum of the deviations, and divide by how many numbers you had, which actually the mean deviation is not a very useful thing. And then we have variance, and you see there the definition of variance. It's the average of the squares of the values of the deviations. The parameter of variance, remember we have parameter versus statistic. This is how you find the parameter value for variance. We use this small sigma, that's a lowercase sigma squared, equals the sum of squares of the deviation. So remember we're using mu for deviation, and so we have the data value minus mu squared over n, and then the statistic, remember we use just our letters, s squared is the sum of all of our data values minus the mean squared, and then we actually divide by n minus 1, so 1 less than how many data values that we have, and that is called the variance.
Just the number.
If you end up taking the sum of the squared deviations, it's also important, and we actually just say SS because that's the sum of squares. Capital S is what's in the numerator there. So the sum of squares is something that we'll be using. Oftentimes in lists we'll put sum of squares or to help us out and to write that instead of having to write it every time.
Let's take a look.
So now remember B and C had the same mean of 6, they had the same median of 6, and their range was the same, but they're not the same list, so we want to find their spread. So again, mean is 6. And so you see here, we're taking, so the mean, for some reason, the little line for the mean got under the x instead of over it. So we've already seen these first two columns in B and the first two columns under C. That's our data values, and then the deviations of each data value. Those end up equaling 0. And then we have our variance, or sorry, not our variance yet. We're getting to our variance. So we square each value. So 4 squared is 16. 2 squared is 4. 0 squared is 0. Negative 2 squared is positive 4. And negative 4 squared is positive 16. So we see there that SS, which remember that means sum of squares, and that is 40. And we can go ahead and do the same thing over with list C. So what we're going to do is we're going to take our sum of squares. We want to find our variance, so we take the sum of squares and divide it by n minus 1. We have 5 values, so 5 minus 1 is 4. So our variance for list B is 10, and then our variance for list C, we take our sum of squares, which is 32, and divide it by 4, which is 5 minus 1, which gives us 8. So finally we have a different statistic here for B and C that shows a little bit of a difference, and we see that the spread of list C is 8, or the variance is 8, so it's less than list B. And that's because all these 6s are grouped together in list C, so overall the values aren't spread out as much. We have a 10 that's pretty high and a 2 that's pretty low, but other than that they're pretty close together. So the next really important topic in statistics here is the standard deviation, and it's actually pretty simple. Once you find everything else, you just simply take the square root of the variance. So there you see it for a parameter. You have sigma, because it was sigma squared, but now it's sigma equals the square root of the variance, and then the same idea for the statistic for not the whole population. So this is what we use for measuring spread in a list of data. So just to show you, the variance in list B we knew was 10. We found that in the last slide, and the variance for C is 8. You take the square root of those to find the standard deviation. So the standard deviation for B is 3.16.
So let's go ahead and
so
look at
here we have
one
another
example.
list
It says find
values.
the sum of squares,
And we want to find the sum of squares,
which is s squared.
and we want to find
S,
the variance, which is s squared, and then we want to find s, which is the standard deviation.
So what we're going to do first is
so obviously the first thing
go
we
ahead
need to
and make
do
a table with our
is
values,
find the
and we'll list here on the left
mean,
our data
because
values.
we have to have the mean
there
in
are
order
1,
to
2, 3, 4, 5,
find
6, 7,
each
8 of them.
deviation.
And once we have them, we want to sum them up.
Then we
because need
can
to find the
move
mean.
forward from there. So we added all those up, 298. 298 divided by 1, 2, 3, 4, 5, 6, 7, 8 is going to give us our
98 divided by 8 is 37.
So you can figure out what that is equal to. 298 divided by 8 is 37.25. So that's our mean, our average of all those values. And now we can go through our column and we can find each deviation. So we'll take 23 minus that mean, and then 29 minus the mean, and 34 minus the mean.
To get all of this,
through that,
put all of them in
and
there.
put all of those values in. So there they are. I know you won't get them that quickly, but it is easy to do. You just do the subtracting.
The sum of
and
our
then
of these
we're going to
values
find
is 0. So
the
what
sum
we
of
want to do is we
squares.
want
In
to
order to find the
square
sum of
these.
squares, we need to find each square,
So this
which
is
really, that idea is
working
it's
to
making
get
everything
our sum
positive.
of
It's showing
squares.
how far those things are from
And so we'll square each of our data values, which ends up making them positive, which is
mean.
helpful.
So we're squaring each of those. There you have those. Again, you can
this
do
would
those
take some
very
time
easily. Take some
calculating.
time, but and then adding them all up,
So
we
down
get
here, we actually have our sum of
525.5,
squares.
which is our
So our sum of squares
sum of squares.
is
Capital S, capital S.
525.5.
So what do
Now
we
we
do
can
with
find
that?
S squared. So this is
We found our sum of squares, which is the
S,
first thing we want to find.
which is
Now
a
we want to find the
statistical
variance,
value.
which is
So we're going to take our
S
sum of squares
squared.
and we're going to divide by
So
n
remember,
minus
to
1.
find variance,
so remember we had 8
we're going
values.
to take that sum of squares and divide it by n minus 1.
So there's our sum of squares. Divide
So
by
we had 8 data points, n minus 1 is 7,
gives us
525 divided 0.5 divided by 7
and then to find our
is
standard deviation,
75.07.
or S,
That
we take the
is
square root
our
of
S squared.
75.07.
And then, which is
we
variance,
get
and then to find our standard deviation, we take the
8.6.
square root of that,
So
and
8.66
we get
is the standard deviation. We're going to be
8.66.
seeing this idea of standard deviation a lot as we work through these.
And that really measures the spread of